Section 2.1.3, the electric field. Suppose we have a lot of source charges, you know, Q1, Q2, Q3, etc. And we place our test charge, you know, somewhere out there. Each of these is going to have their own R vector. And the force of the total force acting on Q is simply, you know, the sum of the forces. So the force is equal to 1 over 4 pi epsilon naught Q1Q over R1 squared R1 hat plus 1 over 4 pi epsilon naught Q2Q over R2 squared R2 hat, and so on and so forth. And if you factor out that Q, then you're left with this stuff on the inside, squared Q2 over R2 squared R2 hat. And you can just write this out this way as the sum of 1 over 4 pi epsilon naught Q sub I over Ri squared Ri hat. And this is actually, this little bit right here, we're going to call that the electric field E vector. It's a vector field, of course. And so depending on what point you choose to place that test charge, you're going to have a different calculation for what the electric field would be, based on how close or far you are to those charges, which direction it's pointing and such. And the magnitude of the electric field represents you know, how strong that field is, or how strong a force a test charge would experience if it were placed at that point. It also points in the direction that a positive charge would move if it were at that position. So if the electric field points this way, then put a positive charge there, it's going to move this way. It's going to have that force that way. But if you put a negative charge there, it's going to move in the reverse direction. Its units are pretty obvious. It's force per unit charge. It pretty much, one of the things that is interesting is that the way I've introduced this electric field, it looks just like a mathematical crutch, and it really is. But as you work through the math and as you see that energy is actually stored in this field, and it becomes almost alive, as something that's completely different than charge, different than anything we know, but just as physical as anything else. And you know, Maxwell, he thought of that this electric field was actually like a manifestation of the ether that exists everywhere, that's the substance, the material through which electromagnetic waves would wave through. Einstein, of course, showed us that that ether doesn't exist. It depends on your reference frame, not on some universal reference frame. But the E field is still something very physical, very real. And just think of it as the thing that fills the space between charges. It fills every point in space at all times. It exists everywhere all the time.